In this video, class 10, we are going to deal with some of the numericals. Okay, I have done 5 numericals here, okay, from the topic work, power and energy. So without wasting time, let us start with the first numerical. So I've started with some easy ones. So it says find the gravitational potential energy of 1 kilogram mass kept at a height of 5 meters above the ground, okay, and the acceleration due to gravity is given to be 10 meters per second squared. All right, so we always start with what is given. Okay, what are the things that are given? So given mass m is 1 kilogram, height h is 5 meters, and acceleration due to gravity is 10 meters per second squared. Remember, gravitational potential energy, okay, is given by mgh, the product of the mass, the acceleration due to gravity, and the height. Okay, higher the body is, higher a body having a certain mass is from the ground, okay, more is its potential energy, remember. Okay, and if we are talking about the same height, two different bodies having different masses will have different potential energy, of course. The one having greater mass will have a greater potential energy. Okay, so this is a very simple problem. So gravitational potential energy is given by mgh. So m is 1 kilogram, g is 10 meters per second squared, and height is 5 meters. So therefore you do the mathematics, and multiplication 10 into 5 is 50, into 1 is 50, of course. So 50 into kilogram, meter into meter is meter squared per second squared. Now kilogram meter squared per second squared is what is called joule, remember. So therefore the gravitational potential energy is 50 joules. Second question, calculate the height through which a body of mass 0.5 kilogram is lifted, in which the energy spent in doing so is 1 joule. Again, g is given to be 10 meters per second squared. Now in this question you need to find the gravitational, what is that? The height. Okay, you need to find the height in this particular problem. Okay, when the energy needed to lift a body having mass this much, 0.5 kilogram, is given. Okay, so given, again we start with what is given. Mass is 0.5 kg, g is 10 meters per second squared, energy spent is 1 joule. Now remember, amount of work done and amount of energy spent, they are one and the same thing. Now in order to do a certain amount of work, okay, in order to do some work, we need to spend energy. All right, now the amount of energy that we have spent to do the work is equal to the amount of work done. Remember that the amount of energy that we spend, okay, is equal to the amount of work that is done. Remember that. So work done to lift the body is given by, so since energy that is needed to lift the body is given to be 1 joule, so therefore work is 1 joule amount of work is also done. Okay, to lift the body, 1 joule amount of work is done. So 1 joule work is force into distance, we know that, or force into displacement rather. So work is force into displacement. Force is mg. Force is always mass into acceleration, don't forget. Okay, so this is the force of gravity. Mg is the force of gravity acting on the body of mass m, into h. Now m is given, g is given, we need to find h. So it's pretty straightforward then after. Okay, so 1 joule is 0.5 kilograms, substituting the value of m, that of g, and we need to find h. So h is 1 kilogram meter squared per second squared divided by 0.5 kg into 10 meters per second squared. Okay, and you do the math, you'll get 0.2. Of course the unit will be meters. Why? Because this kilogram, they divide each other out. This meter and 1 meter from here, they divide each other, and second squared, they divide each other. So what we are only left with is mass, meter. So this is 0.2 meters. So height through which the body is to be lifted is 0.2 meters. Now question number 3. Two bodies of equal masses are moving with uniform velocities v and 2v. Find the ratio of their kinetic energies. Okay, so the question says, the question is talking about two bodies having equal mass. Okay, the velocities are different. The velocity of one of the bodies is v, and that of the other is twice that of the first body. So that this is 2v. So we need to find the ratio of the kinetic energies. So what we are supposing is, let the masses of the two bodies be m, okay, and we know kinetic energy is given by what? Half mv squared. Kinetic energy, remember, is given by half mv squared. Potential energy is given by mgh. Okay, so therefore kinetic energy of the first body, we are calling it k1, is half mv squared, since the velocity of the first body is v and its mass is m. Kinetic energy of the second body, we are calling it k2, is half m, but its velocity is 2v according to the question. So according to the question, the velocity is 2v. So kinetic energy of the second body is half m 2v squared. Okay, half into mass into velocity squared. The velocity is 2v, so therefore we have 2v whole squared. So this comes out to be, okay, this will be half m into 4v squared. All right, so this 2 divides that 4 and we get 2mv squared. So k2 is 2mv squared. Therefore the ratio of the kinetic energies, okay, will be k1 is to k2, which is half mv squared is to 2mv squared. So this comes out to be 1:4. Sometimes the question will be like, compare, okay, it won't be straightforward like this, find the ratio of the kinetic energy. Okay, it will simply say compare the kinetic energies of the two bodies. All right, so whenever the question says compare also, you will find the ratio and show it this way, remember. Okay, so this is question number 3 and question number 4. A truck weighing 1000 kilogram force. So the weight of the truck is given, which means its mass is also known. Its mass is 100 kg. Changes its speed from 36 km per hour to 72 km per hour in 2 minutes. Okay, so a truck having mass 1000 kilogram, okay, is increasing its velocity or speed from 36 km per hour to 72 km per hour, and that happens in 2 minutes. So the question says, calculate the work done by the engine of the truck, of course, and its power. Again, g is given to be 10 meters per second squared. So we start with what is given. Given mass is 1000 kg. Okay, since the weight is 1000 kgf, its mass has to be 1000 kg. Now initial speed. So since there is a change in speed or velocity of the body, so this was the initial speed and this is the final speed. So we are terming this, we are calling this the initial velocity or the initial speed, and this is the final velocity or the final speed. So initial velocity, we are denoting it by u, is 36 km per hour. But remember, most cases we are to work in SI system of units, and if not SI, okay, we are to work in the same system of units. Remember, if you are comfortable working in CGS, okay, you work in CGS system of units. If you are comfortable working in SI, you work in SI system of units. But the council prefers SI system of unit. Okay, so therefore we have to work in the same system of unit. So 36 km per hour, this is in kilogram, this is SI. Kilometer per hour is not the SI unit for speed. So therefore we need to convert this to meter per second. Alright, because this is not the SI unit. So kilometer per hour is 36 into 1000 meters, because 1 kilometer is 1000 meters, divided by 1 hour is 3600 seconds. Okay, so u comes out to be 10 meters per second. Likewise, final speed v is 72 km per hour. So I've converted this also to meter per second, which is 20 meters per second. Okay, and time of course is given to be 2 minutes, which is 120 seconds. This also is not SI, so I've converted it to SI. So all of these are now in the same system of unit. This is 1000 kilogram in SI, this is in SI, this is in SI. Okay, the final velocity or final speed, and the time is also in SI now. Now we've converted all of the units to the same system of units, which is SI in this case. Now this particular problem, by the way, okay, since the question says find the work done by the engine and the change in speed is given, the mass of the body is given, remember this particular problem is an example of work energy theorem. Okay, I had made a video on work energy theorem. Okay, I hope all of you have checked that. Okay, so this particular problem is based on work energy theorem. Now the question says find the work done by the engine. Okay, so the mass is given, the speed is given, initial speed, so we can find the initial kinetic energy of the body. We can find likewise the final kinetic energy of the body. Now, since we can find, therefore, the difference or the change in the kinetic energy of the body, the change in kinetic energy of the body is what is equal to the work done. And this we get from work energy theorem. Remember that. So that is what I've written. So now work done is change in kinetic energy. Of course, we get this from work energy theorem. Remember that. Okay. So therefore, work done is half mv squared, the final kinetic energy, minus the initial kinetic energy. So I've taken half m common. So this is v squared minus u squared. Then after I've simply substituted the values. So half into mass is 1000 kg. V, we've seen V in SI is 20 meters per second. So this is 20 squared. V squared is 20 squared. Minus U is 10 squared. Okay. And the square of the velocities will have units. Since we are squaring the velocities, the unit will be m squared per second squared. Okay. Then after, we simply have to deal with the mathematics, go on simplifying it. So half into 1000. Okay. I haven't written the units over here. Into 20 squared is 400, minus 10 squared is 100. So this comes out to be 1,50,000 kilogram meter squared per second squared. Now kilogram meter squared per second squared is what is called a joule. Remember that. Okay, so after we've calculated the change in kinetic energy, we get the work done, because change in kinetic energy is what is equal to the work done. Remember. Now the second part of the question says find its power. Okay, now after we calculate the work done, finding power is no big deal, because power is simply work upon time, the rate of doing work. Okay, so this much is the work done, divided by time is 2 minutes. The question says 2 minutes, and we've converted that 2 minutes to 120 seconds. Okay, so the time is 120 seconds. So 1,50,000 joules divided by 120 seconds is, or will give you 1250 joule per second. Joule per second is what is called watt. Okay, so this is how you do this problem, remember. All right. And finally, we come to the fifth problem. The fifth problem is this. A bullet of mass 50 grams is moving with a velocity of 500 meters per second. So the question talks about a bullet having mass 50 grams and it's moving with a velocity of 500 meters per second. Quite a velocity this is. Okay, in 1 second 500 meters. Okay, then further it says it penetrates 10 centimeter into a still target. Okay, so we have a still target, say for example a wooden board. All right, now the bullet hits the wooden board and penetrates 10 centimeters into it. Then after penetrating 10 seconds, what happens is the bullet comes to rest. The bullet comes to rest after penetrating 10 centimeters inside the still target. Then it says calculate the kinetic energy possessed by the bullet and the average retarding force offered by the target. Now I didn't find this particular thing very clear, the kinetic energy possessed by the bullet. Okay, the question had to be more specific, because since the bullet comes to rest after penetrating 10 centimeters, okay, its final kinetic energy is of course 0, because its velocity is 0 finally. Okay, so this kinetic energy, the question is talking about the kinetic energy possessed by the bullet before it hits the target. Just before it hits the target, what is the kinetic energy of the bullet? Okay, that is what the question is trying to say over here. All right, so be clear about that. So let us start with what is given. Given mass is 50 grams, which is 0.05 kg, of course. I am again converting to the same system of units. Initial velocity is given to be 500 meters per second, because the question specifically says before penetrating or hitting the target, the velocity of the bullet is 500 meters per second. Okay, so initial velocity u is 500 meters per second. Final velocity v, of course, is 0, because the body eventually comes to rest. The bullet eventually comes to rest. And the distance moved inside the target is 10 centimeters. Again, I'm converting it to the same system of units, which is 0.1 meters. So, therefore, I have specifically written over here, kinetic energy of the bullet before it hit the target is given by half mv squared. Kinetic energy is half mv squared. So half into mass is 0.05 kg into velocity squared is this much, 500 meters per second whole squared. Okay, then after simplify, you do the mathematics, check the mathematics, the kinetic energy comes out to be 6250 joules. Okay, so whatever is the kinetic energy, okay, so work done to stop the bullet therefore is 6250 joules, because see, before you hit the target, the bullet had kinetic energy this much and its final kinetic energy was 0. So there is a change in kinetic energy from this value to 0. Okay, now to stop that bullet from when it possessed this amount of energy to when it possessed 0 amount of energy, kinetic energy, okay, there had to be work done. Okay, work had to be done, and work is being done by the target, still target. Okay, so the change in kinetic energy from this value to 0 of the bullet, okay, is brought about by work done by the still target, and the work done to stop the bullet therefore is this much. Again, work energy theorem over here, mind you. Okay, because there is a change in kinetic energy from this value to this value, so this change in kinetic energy has to be equal to the work done. So work done to stop the bullet is this much, remember. Okay, now why are we talking about work done? Because the second part of the question says find the average retarding force offered by the target. Okay, since the question says find the what is the value of the force, okay, the still target of course is exerting some retarding force because of which the bullet eventually stops. Okay, so to find the retarding force we have to talk about work done. All right, so work done to stop the bullet is this much. All right, so therefore this amount of work done has to be equal to retarding force into the distance moved, because work done is force into displacement. All right, so 6250 joules is retarding force, we are calling it F, which are we required to find. So F into distance moved is 0.1 meters, because the question says distance moved is 10 centimeters, which is 0.1 meter. So therefore force will be how much? You do the math then after. 6250 joules divided by 0.1 meters. Okay, it comes out to be, the retarding force comes out to be 6500 Newton. Okay, look at the units over here. Kilogram meter squared per second squared is joule divided by meter. So this meter and 1 meter over here, they divide each other. So we are left with kilogram meter per second squared, and kilogram meter per second squared is what is called Newton. Okay, kilogram meter per second squared is Newton. Kilogram meter squared per second squared is joule. Okay, so we can also write 1 joule is 1 Newton into 1 meter. Newton meter is also called joule, remember. So here, coming back to the problem, so retarding force is 6500 Newton. So therefore retarding force required to stop the bullet is 6500 Newton. Okay, in the next video we are going to deal with some numerical problem for machines, then after we'll start sound. Okay, all right, take care class 10. Okay, thank you.